Good day, guys. So this short video that we're going to try to keep it short is going to be about a compilation of around 30 questions by GYAN, and this is mainly for the interview of ANGLO done by Berganza sir. So we have past students, etc., who have shared their experience, and from that we have compiled this set of 30 questions, which can serve as a very good question bank almost. Not only for this, but even for other company interviews for GME, you can use the same material because knowledge is universal. So it will definitely be a lot of value added to all of you guys. So what you can do is you can pause the video after you hear the question, because it will be a question answer format in this video. So you can pause the video, you can write down your answer on a piece of paper, and then you can resume and have a look and check out, have you missed out any important points or something like that, and that can help you improve. Again, if you still have further questions, you always have the WhatsApp group. You can come in, ask any of your doubts, and we'll clear it as soon as possible. But for now, I think Gyan, I think we can start it out.
Okay, I am ready.
Okay. So question number one is, explain for me the centrifugal pump along with the parts.
Okay. Basically, centrifugal pump is a rotodynamic pump which works on the principle of centrifugal force. The suction pressure created at the eye of impeller, and that is negative pressure, and it causes fluid to displaces radially outward toward the discharge side when impeller rotates. And talking about its parts, the starting with the down, it has foot valve. Its foot valve, that is non-return valve, to flow the direction, to maintain the one way direction of the fluid. And the second is strainer, that is a kind of filter. Now we have a suction pipe going through the up eye of impeller, that is the region where negative pressure is created. Then we have casing, and through the eye of impeller, the rotor shaft is connected, and in casing and eye of impeller there is some space. In that space, seals is there for seals, and it is of two types: mechanical seal, blunt packing seal. Okay, now coming to that impeller, after eye impeller, it is connected with the blade. It has blades, that is backward curved blade. Why backward curved blade? Because it minimize turbulence. Okay, for proper efficiency and all. And now the direction of impeller will rotate in that direction in which the fluid will go toward the discharge side of volute casing. Now coming to the volute casing, the size of volute casing keeps on increasing, and now going to the, that is called delivery pipe. Okay, delivery pipe, after delivery pipe we have discharge valve. We keep discharge valve shut during starting. Have I missed any part?
Yeah, for now it's good. Motor, shaft, all of that will be connected, and that's how we'll have the rotation. So next question coming is going to be, how is this negative pressure created inside the centrifugal pump?
Okay. First, the negative pressure is created at the eye of impeller. Okay. When the impeller rotates, when we start the motor, when the impeller rotates, it exerts a centrifugal force to the fluid particle, due to which fluid particles displaces radially toward the discharge side of volute casing, and and due to which a wide space or negative pressure is created at the negative pressure region, low pressure region created at the eye of impeller, because that fluid is displacing radially outward, and by displacing there is a wide space, that is the low pressure region, and due to which fluid gets sucked into the eye of impeller, because fluid flow from high pressure to low pressure. At the eye of impeller, it is first creating a low pressure, and from the downside it is high pressure coming here. Got it?
Okay.
If anything I by mistake I speak wrong, then please correct me. Okay.
Yeah, sure. So this was now about negative pressure.
Yeah.
Tell me, what about the discharge side pressure in the centrifugal pump?
Okay.
How is that taking place?
Okay. First, the discharge pressure is created because of the design of the volute casing of centrifugal pump, whose volume keeps on increasing. Okay. When we start the motor, the impeller rotates and it imparts kinetic energy to the fluid particles, and due to which, because of centrifugal force exerted by impeller, and due to which fluid readily displaces outward, pushed readily outwards, and when this fluid goes through the discharge side of volute casing, the as volume keeps on increasing, due to which the velocity of fluid decreases and hence causing kinetic energy decreasing. And the moment kinetic energy decreasing, pressure energy is increasing, and due to energy conservation principle, and this is how the discharge pressure is created in centrifugal pump. It's all about energy conservation principle and the design of the volute casing.
Okay, great. So this was all about the discharge pressure. But what will happen if suddenly air enters inside the centrifugal pump? Tell me about that.
Okay. Okay. Since air is compressible, okay, and having density less than having density 1000 times less than the density of water, so the amount of centrifugal force exerted by impeller will become 1000 times less because of that formula m r omega square. M density is decreasing and volume is constant, so by formula we will get 1000 times lesser, and due to which it will not able to create enough suction pressure at the eye of impeller, and what happened, it will not be able to suck the fluid and impeller will keep running dry. There will be no discharge taking place. So we can say that the pump efficiency, pumping capacity will decrease drastically, and due to this key dry run of impeller, it will cause overheating. That's why priming is very important, very important.
Okay, so again, you talk about the word priming. Explain to me exactly what it is, how it is done.
Basically, priming is the process of removing air, gas or gases that trapped in the system with the same liquid which is being pumped. There are various type of priming method. The first one is manual priming. From priming port, we can first fill all the suction pipe, the discharge pipe with the fluid, and the second method is that using external source, means using external source to push the liquid into the casing, and that causes gases to
Okay, guys, so we had a slight network issue in the middle, so we'll just resume back again and restart with priming. So, Gyan, what is priming?
basically, priming is the process of removing air from the pump and filling with the same liquid that is being pumped. Okay, there are various type of primings. Manual priming, the first manual priming means priming with like manually priming using priming port, filling the liquid in suction pipe, casing, delivery pipe, hole. Okay, and the second is using external source. In external source we can use something that pushes fluid inside the pump. Okay, and on board ship we use vacuum pump to suck the fluid and make the to suck the air and make the fluid to come in, and that vacuum pump is a type of reciprocating pump we use along with the centrifugal pump. Okay, that is fitted at the suction side of impeller, like before impeller at suction side. Okay.
Yeah, okay. So that's good. So now tell me, why is the discharge valve shut while starting of the centrifugal pump?
The discharge was shut during starting of the centrifugal pump for two reasons. The first is to save the power consumption, and the second is to prevent the motor from overheating. Whenever motor start, there is a starting torque required because it has to rotate the impeller from the rest position and to bring it at fixed RPM. So initially when motor start, it draws a lot of current because lot of current to compensate the inertia of impeller. On the other hand, we also know that whenever there is fluid flow in a case of centrifugal pump, whenever the flow of fluid is more, it draws a lot more current. So if we keep discharge valve shut, we will be saving that excessive current that is the required for flow. And if you do not keep discharge valve shut, the motor will draw a huge amount of current. Okay, and that can cause overheating, that can eventually damage the pump, and the power consumption will be more overall. So this is the reason, to avoid this we do that. Anything I left?
Okay, so that's fine for now.
Mm.
Tell me about cavitation and NPSH.
Okay, concept of NCS. Okay. Cavitation is the formation of vapor bubble. Okay. Whenever the pressure in the pump decreases below the vapor pressure of the fluid that is being pumped. Okay. And when this vapor bubble enters into the high pressure region, that is the discharge region, it bursts. And when it bursts, it causes impinging action, pitting action on the impeller, tuck tuck, and eject some material that in that causes losing of strength of impeller. So the amount of centrifugal force, the efficiency of pump will decrease, and the lifespan of the pump will also decrease, like eventually. So uh, so that is the cavitation, and that is, so to prevent cavitation we have a concept of NPSH. There are various methods of to prevent cavitation. One of the method is that ensuring NPSH, to also ensuring that motor should not run at excessive speed, because it can cause turbulence, and due to turbulence the local velocity will increase, and that causes the fluid to boil faster and making formation of boiling. So now coming to the NPSS thing, and also due to all this the temperature of the pump can increase due to this liquid evaporate from vapor. Coming to the NPSS thing, NPSS stands for net positive suction head, and it represents the amount of pressure present at the amount of pressure head that present at the inlet of the pump, and that is above the vapor pressure of the fluid that is being pumped. Okay. So, and it is very necessary that the NPSH available should be greater than the NPSH required. NPSH required is given by the manufacturer, and NPSH available is that criteria, that at how much height we are sucking the fluid. Okay, that due to which NPSH available is enlarged and measure the thing. Thank you.
So, as you mentioned, NPSH available is not only based on of what the height is, but also based on other factors such as the vapor pressure, the atmospheric pressure, and
Yes,
as
yes,
per the
yes,
formula.
yes, yes. Thank you.
Okay. So, tell me about positive displacement pumps, in specifically gear pump.
Okay. Gear pump is a type of positive displacement pump in which the mechanical meshing of the gears create a pumping action. Okay. Transfer the fluid from one place to another. Okay. It has got two gears. One gear is driving gear, the other gear is driven or follower gear. Driving gear is connected with the engine shaft, and when this driven gear rotates, or when this gears rotate in a closed casing, okay, one side they get out of the mesh, and one side they get into the mesh. The side where they get out of the mesh, there they create additional volume, and due to which the pressure decreased and become lower than the atmosphere pressure, and that that causes suction, that is known as suction pressure, that creates a negative pressure, that is a creation of negative pressure, due to which, and that suck the fluid. And when fluid gets sucked, due to which, and it gets sucked between the three teeth of the gear, and trapped between the teeth of the gear, and due to mechanical meshing of the gear, it through the parameter of the casing, it pushes through the discharge side. At discharge side the gear come into the mesh. Okay, and when they come into the mesh, the volume get decreased, due to which pressure increased, and that is how we get the pressurized air, pressurized fluid at the discharge side of a gear pump. At discharge side we have a relief valve, because positive displacement pump safety is very necessary. It displaces positively the fluid. Thank you.
Okay. So, give me some points on how is this pressure you've already mentioned, in how the discharge pressure is created you've already mentioned.
Mm.
So give me some points and some differences between the centrifugal pump and the positive displacement pump.
Starting with the principle, centrifugal pump is the works on the rotodynamic principle, okay, in which the impeller rotates or create a pumping action. Okay, positive displacement pump works on the positive displacement principle. It positively displaces the fluid, it traps the fluid and positively displaces. These are the working principle. Now coming to the application, centrifugal pump used for high discharge flow. Where high discharge is required and low pressure is required, there centrifugal pump is used. Where low discharge is required and high pressure is required, there positive displacement we use. Coming to the efficiency, in centrifugal pump, since efficiency depend on the flow, and in the flow, more is the flow, efficiency is flow, the more the efficiency. In positive displacement pump, efficiency is constant because flow is constant. Why flow constant? Because what is positively displaced is does not depend like a impeller rotation and air and all, it just positively displaces. And the next difference is that centrifugal pump requires priming. Okay, positive displacement pump do not require priming. Centrifugal pump, in centrifugal pump the suction and discharge direction are in perpendicular to each other, suction discharge. In positive displacement pump, they are parallel in the direction, parallelly. In centrifugal pump, there is no pressure relief valve required because the working pressure is not that much high. In positive displacement pump, working pressure is so much high, that's why relief valve is required. So these are the differences I can remember right now. And I can also
Okay.
I can tell you one also thing, that in a case of centrifugal pump, uh, uh, I had tell I think flow is not constant, but in a case of positive displacement pump, flow is constant. Okay.
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 So next thing is, what is the difference between the reciprocating and rotary pump?
Reciprocating and rotary pump, okay, they are both type of they are both positive displacement type of pump, okay, but the major differences is in reciprocating pump, the principle is they uses piston plunger movement to create pumping action. In rotary rotodynamic, they uses gears, motors, rotors, screw rotors, vane, lobe to create a pumping action. In a reciprocating pump, the flow is non-continuous, intermittent flow. One time it sucks, other time it's uh, discharge. So pulsating flow is there, but and hence air vessel is required. And in case of rotary pump, the flow is continuous, no air vessel is required. Reciprocating pump working pressure is comparatively high, the working pressure is comparatively low, then it required rotary reciprocating pump required more space, here rotary pump required less space. The categories of reciprocating pumps are, the first one is piston pump, plunger pump, and hello.
Okay, fine. So
Okay.
next you proceed to differences between.
The next difference is the categories of reciprocating pump. It has piston plunger pump. The second is diaphragm pump. In rotary pump, we have gear pump, screw pump, lobe pump, vane pump. Yes. The next question.
Okay, so the next question comes as differences between two-stroke and four-stroke diesel engines.
Okay. In two-stroke engine, the whole cycle of intake, compression, power, and exhaust is completed in 2 stroke of the piston. In 4-stroke engine, the whole cycle of intake, compression, power and exhaust is completed in 4-stroke of the piston. In 2-stroke engine, the crankshaft revolute once for every complete combustion cycle. In 4-stroke engine, the crankshaft revolute twice for every complete combustion cycle. In 2-stroke engine, the crankshaft and camshaft rotate with the same speed. In 4-stroke engine, the crankshaft rotate twice at the speed of the camshaft. In 2-stroke engine, the crankshaft and camshaft are connected with the chain drive or bell drive because they rotate with the same speed. In 4-stroke engine, the crankshaft and camshaft connected with timing gear because they rotate with the different speed. In 2-stroke engine, it has scavenge port and exhaust valve. In 4-stroke engine, it has both inlet valve and exhaust valve. In 2-stroke engine, it has just in 2-stroke engine, it has scavenge port and exhaust valve. In 4-stroke engine, it has both inlet valve and exhaust valve. In 2-stroke engine, the power to weight ratio is more. In 4-stroke engine, the power to weight ratio is less. In 2-stroke engine, it is lighter flywheel required because it produces less torque. In 4-stroke engine, it is heavier flywheel required because it produces more irregular torque. In 2-stroke engine, it produces less irregular. In 4-stroke, it produces more irregular. That's why higher, heavier flywheel is required. In 2-stroke engines are generally simple design engines. They have less moving part. In 4-stroke engine, it is a complex design of engine having more moving parts. 2-stroke engine produces more noise. 4-stroke engine produces less noise. 2-stroke engines are bidirectional engines. Generally, 4-stroke engines are unidirectional engines. 2-stroke engine on board ship is used as main engine. 4-stroke engine is used as auxiliary engine. And in 2-stroke, the length of the stroke is relatively longer. That's why the cross-head bearing is required to convert the rotary motion of the crankshaft into the reciprocating motion of the piston, and hence called cross-head engines. In 4-stroke engine, the length of stroke is relatively shorter, and that's why it's called trunk type, and no cross-head bearing is required, and hence it is called trunk type engine. In 2-stroke engine, the stepping box is required because to separate the crankcase and cylinder space, because two different quality of lube oil is used for lubrication purpose. In 4-stroke engine, there is no stepping box required because same quality of lube oil is used for lubrication purpose. Thank you.
Okay, so tell me about some auxiliary engine safeties.
Okay, first the cross question had come that why stepping box is required in 2-stroke engine. I would like to explain that.
Okay, sure.
Okay, the cross question I face, that is why 2-stroke engine required stuffing box, because it is not very common to speak up about stuffing box and differences. Okay, so I got leverage because I knew the regions about that, and he got impressed. So guys, enhance your knowledge also, and have the guts that you can, if any cross question can be asked, you can clear that, you can explain that. Okay, so I had explained like in this way. Yes sir, in 2-stroke engine, since we burn heavy fuel oil, so the acidic formation is more because of the it produces SOx and non formation, like sulfur dioxide, sulfur trioxide are produced in the cylinder engine, and that is acidic. So for that we require high TBN lube oil. High TBN means high total base number. That is the basic in nature, which neutralizes the acidic formation in the cylinder engine, and that is very costly. So that's why we don't use both for both same type of oil, because on board ship in 2-stroke engine, like a large quantity of lube oil is used, like up to 10 to 13,000 liter per day on a daily basis. That's why we have stuffing box to separate that.
Okay, fine.
I hope I
So
have
now
made
that you have
clear my
cleared that
point.
out,
Ma- hmm.
what are your auxiliary engine safeties?
Okay, starting with low lube oil pressure alarm and trip, high jacket water temperature alarm and trip, overspeed trip, fuel oil leak of alarm, exhaust gas high temperature alarm, scavenge air high temperature alarm, starting air low pressure alarm.
Okay, fine. What about the main air compressor safeties?
Yeah. Relief valve is fitted at every stage of compressor. Busting disc and casing of the intercooler and aftercooler. Fusible plug at the air receiver, air bottle. And the thing is low boil pressure alarm tip for compressor crankcase. Now water high temperature trip, water no flow trip, motor overload trip. Should I explain water high temperature trip, water no flow trip, why it is required?
Sure, sure.
Okay. Water high temperature trip is required. Trip is given when there is a chances of choking of intercooler, like less supply of water inside that. So in this case, if there is less supply of water, then the air compressor will get overheated because it is being cooled down by the intercooler, aftercooler, the water that. So because of that, the temperature of water will increase, and that's why this water high temperature trip is given to get trip, cut off the compressor, cut off the fuel, and turn off the system. Okay. Water no flow trip. Water no flow, it's come from its name, that for pumping liquid, it is trip given for the fluid pump, which is used for the pumping fluid. That in intercooler we to pass the fluid we use pump, and for if that pump is not working, in that case it trip. And now the motor overload trip. In a case of when the motor draws a lot of current, in that case this trip occurs, like this trips cut off the compressor. All good?
Fine. Yeah. So what about your boiler safeties?
Boiler safeties. Yeah. Safeties or boilers are safety valve, air purge valve, fusible plug, low water level alarm and trip, failure flame failure alarm. These are the
Okay,
safeties.
sure. What about refrigeration safeties?
In refrigeration safety, we have low pressure cutout, cut in cutout, high pressure cutout, low lube oil pressure cutout, relief valve, oil heater, solenoid valve. I would like to explain further. Low pressure cutout is given at the suction side of compressor. That is given for whenever there is low flow of refrigerant. Okay, means it is the indication that room has cooled enough. There is no need of using compressor and expending electricity, so it automatically cut off. I said cut in and cut off because cut in also it automatically start also whenever the flow of refrigerant increases, whenever the temperature of the room get increases, it automatically starts. That's why we hear sometimes tripping and tripping in tripping out of compressor, the all of sudden voice in our homes. That is because of low pressure cutout. High pressure cutout, whenever there is a chances of blockage or there is chances of anything that can create a high pressure inside a compressor, so at that time it trips off the compressor to prevent it. Okay. Now low lube oil pressure cutout. Low lube oil in compressor, there is a crankcase. For crankcase bearing and crankshaft we need lube oil. If that pressure or that is decreases, that means the supply of lube oil is decreasing, and that can cause damage to the bearing of the crank bearing and crankshaft and all the things. So for that this trip is given. Now coming after relief valve. Relief valve is fitted after the discharge side of compressor to release the excess pressure. Okay, in a case of if it creates the pressure
Some
over
kind
the
of emergency.
yeah.
Yeah.
And now oil heater. Since oil heater is present in the for the compressor lube oil, because it prevents the lubrication oil to get excessively cold. Okay, it will not able to lubricate properly if get cold because of the refrigerant flow and all. Okay, so
And viscosity also will increase.
yeah, viscosity will increase. Now the next is I have spoken solenoid valve. Yes, solenoid valve is a kind of electronic valve. Okay, and that turns off the flow of refrigerant, overflow of refrigerant. Okay, if flow of refrigerant at the time when
Okay,
compressor gets cut off, in a case of flow of refrigerant less, so it will prevent turn off the overflow of refrigerant. Okay.
sure. Okay, what about the main engine safeties?
Mm,
Finally, to come up close to the safety part of things.
yeah, main engine or two stroke engines, in that we have low lube oil pressure alarm and trip, same, overspeed trip, jacket water cooling temperature trip, piston cooling water low pressure trip, oil mist detector, crankcase relief valve, scavenge space relief door.
Okay,
Should I
so
explain
previously you talked.
all oil mist detector?
Yeah, I think that will be good for the
Yeah,
people.
yeah. Because mm, yeah, oil mist detector is basically a safety device of two stroke engine. Okay, that gives that takes from that we take out the sample of the mist, sample of the lubrication oil, and we check the level of mist in that lubrication oil, that is the what is it is at what level to cause the crankcase explosion. Okay, now the concept of crankcase explosion is coming. To prevent this crankcase explosion, we use oil mist detector. I need to explain what is crankcase explosion. Okay, we know that there is a splash lubrication is required. Okay, for two stroke engine. Okay, and at time the time come when is there is some hot spot region is created because of the rubbing of bearings and all. When this lube oil is splashing now, that got heated, that got in contact with the hot spot and get evaporated, and further when this evaporated lube oil condense in a cold region, it condense in the finer particle, in finer particle. Earlier it was the particle size was big. Now when it condense in a finer particle, that is very volatile, that is very vulnerable to explode or to catch fire. And now this again, when this condensate cloud again goes in that hot spot region, boom, primary crankcase explosion happens, and that causes the high pressure. And in that case, if the crankcase relief valve in the opened, the air from the system environment come, all the thing get blast, all the ship will damage, everyone will die. So to prevent that, we have oil mist detector. If primary explosion is happening, and to prevent that secondary explosion, we have crankcase relief valve, relief door. It is a type of valve. Okay, for the same we have scavenge space relief door to prevent the scavenge space. It is kind of valve, spring loaded valve. Okay, this much.
Okay, so previously you had spoken about the boiler safeties. Now regarding the boiler mountings.
Yeah, boiler mountings are safety valve, air purge valve, steam stop valve, scum blow down valve, boiler blow down valve, steam pressure gauge, water level gauge glass, fusible plug.
Okay, do you want to go in slight brief
Yeah,
of what where they are located and what's the
yeah,
purpose of each
yeah,
one?
sure, sure. First, we have safety valve. In boiler, there are two safety valve are fitted with a with a pressure difference of 0.5 bar. Okay, and it prevents the boiler from over pressurized, like it releases the excess pressure and come down with the much below pressure. Okay, it is more reliable than the relief valve, because relief valve only exert excess pressure only. Okay, now we have air purge valve. Air purge valve is also known as air vent cock. The purpose of air vent cock is that it it maintains the pressure between the boilers and the atmosphere. Okay, there is a case, if the pressure in the boiler get decreased than the pressure in the atmosphere, the boiler can implode. Okay, and if there is a case, if boiler's temperature, like boiler pressure is getting so much over pressurized, so in this case that explode. But for the primary reason, to prevent from imploding, the air purge valve vent cock is given. Okay, in a case when the steam in the boiler get condensed, creating a low pressure, in that case the implosion can happen. So we have vent cock, air purge valve, we open that, from there the air the pressure get maintained. Okay, so that. Now coming to the steam stop valve, it controls the flow of steam. Okay, simply I'm not going to detail into steam hammering, okay, because we have discussed all the time. It is a quite confusing concept for that. Okay, now coming to the feed check valve. Feed check valve is a non-return type valve. Okay, it controls the flow of water from the feed pump. It ensures that the flow of water only go one way, not to return again to the pump. Okay, now scum blow down valve. Scum blow down valve is fitted at the top of the boiler for to clear, to eject the floating debris in the boiler. Now we have boiler blow down valve, that is down bottom of the boiler, to clean the things, mud and all. Coming to the steam pressure gauge, we have a steam pressure gauge to measure the pressure. Water level gauge at the front of the boiler, front face of the boiler, to measure the level of water in the boiler. It is more or less, if it is less, that it can cause temperature high, and temperature of the boiler can get to the high temperature than just temperature, and for that temperature we have fusible plug. Fusible plug is a kind of a safety device that is also present in the boiler and in the compressor also. It is a threaded cylinder device which is tapered, and inside that a uh, low melting point material is there, which get melts and create a passage from which the excess air, the heated air, gets out and lowering the pressure and temperature of the boiler or compressor. I think I have made clear. Thank you.
Okay, great, great. So tell me about Faraday's law.
Yes, basically Faraday's law predicts or defines the relation between an set of conductor and a magnetic field for an induction of EMF, electromagnetic motive force. It has got two laws. The Faraday's first law states that whenever there is a relative motion between an electrical circuit and a magnetic field, there will be the electromotive force induced. And second law states that the magnitude of this induced EMF will be equal to the amount of magnetic flux that is linked with this electrical circuit or set of conductor coils. It is given by the formula EMF equal to minus and d phi by dt, where minus is the sign given by the Lenz law.
Okay, so you mentioned Lenz law, so give me some more clarity on what is
Yes, sir.
Lenz law.
Basically, Lenz law is a consequence of Faraday's law. Okay, it tells about the direction of the induced magnetic field that is produced because of induced electromagnetic force, and whose direction is opposite to the direction of existing magnetic field. That's it.
Okay, great. So what about Pascal's law?
Okay. Basically, Pascal's law states that whenever when pressure is applied to an incompressible fluid in an enclosed region, this applied pressure will be equally transmitted in all directions. We use Pascal's law in various applications like lifting of heavy object, hydraulic jets and all. Thank you.
Okay. So what is Archimedes' principle, and just give me some example to understand this.
Okay. Archimedes principle states that whenever a body submerged partially or fully in a fluid, an upward force, that is buoyant force, will act in upward direction, and that will be equal to the weight of the fluid that is displaced by the body. It is given by the formula buoyant force equal to rho Vg, where rho is the density of the displaced fluid, V is the volume of the displaced fluid, and G is the gravitational acceleration. Coming to the Archimedes principle, because of Archimedes principle anything float. If if the gravitation mg, weight and buoyant force, if buoyant force is more than the weight, then it will float, otherwise it will sink.
Okay, great. So tell me about reflection and refraction.
Okay, basically reflection is the bouncing back of light when it strikes on the solid surface. It has got two laws. The first law of refraction say that the angle of incidence will be equal to the angle of reflected ray or reflection. The second law states that this incident ray, reflected ray and normal will be lie in same plane. Now coming to the refraction. Refraction is bending of light. Whenever the light goes in rarer or denser medium, they bands are okay. So it follows Snell's law. Snell's law is that sin I upon sin R will be equal to the will be constant. Sin I is the incident of sin, incident ray sin, and R is the refracted sign.
And what's that constant?
Constant is the ratio of refractive index of the refracted ray upon incident ray. Like sin I by sin R equal to refractive UR upon UI. UR is the refractive index upon incident refractive index of index ray. Pardon me for fumbling.
Okay, fine. So what are the refrigerants that we use and some properties of the refrigerant?
Okay. The refrigerant we use nowadays, the most common refrigerant is tetrafluoroethane, that is R134A, because it has very low global warming potential and ozone layer ODP, low ODP, ozone depletion potential. And other refrigerant we use are 143A, that is trifluoroethane, difluoroethane, pentafluoroethane, mostly HFCs we use. Okay, hydrofluoroethane. And earlier we used to use R12, that is dichloroethane. Due to chlorine, it got high ozone depletion potential, so that was not good for environment, and so we avoid the use the refrigerant like HCFCs and CFCs, chlorofluorocarbon refrigerant and hydrochlorofluorocarbon refrigerant, that is the freon. So that can cause, that is very hazardous to the environment, so we avoid that. Now coming to the properties of refrigerant, it has got some properties, that is the low boiling point, low condensing pressure, low specific volume, high critical temperature, low global warming potential, low ozone depletion potential, high latent heat of vaporization, non corrosive, non flammable, and highly miscible with the uh, lubrication thing or otherwise. Okay. Now explaining, I will like to explain why low condensing pressure, low specific volume. This is because
Sure, sure.
the compressor size will reduce. Okay. If it will be high, we will have to use a big size compressor, big size system. Okay, that's why. And high latent heat of vaporization is why, like it will extract high amount of heat in converting its phase. That's it will cause more cooling effect. That's why. And also
Okay.
low freezing
So
point.
now,
Yeah, yeah, you can get.
so explain to me the VCRS cycle in detail,
Okay.
along with some parameters of what is the temperature at evaporator coil and pressure at the compressor, etc.
Okay. So basically, VCR cycles involves four stages using four components. The first stage is isentropic compression using compressor. The second stage is isobaric heat rejection, that is condensation, using condenser. The third stage is isenthalpic expansion using thermostatic expansion valve. The fourth stage is using that is isobaric heat absorption, that is evaporation, using evaporator. The cycle begins with the compressor, where the low pressure, low temperature vapor refrigerant comes from the evaporator, enters in the compressor, and it is get compressed into high pressure, high temperature superheated vapor refrigerant. Now this high pressure, high temperature superheated vapor refrigerant will goes into the condenser. Condenser is a type of heat exchanger where this superheated refrigerant rejects heat to the surrounding and changes its phase into a saturated liquid refrigerant at constant pressure, and now this and becomes high pressure saturated liquid with slightly low temperature than the temperature after compressor. Now we have dryer. Dryer contains some silica gel. If there is an environment, there is some moisture in refrigerant, that take care of it. Now it will move to the thermostatic expansion valve. Now this saturated liquid refrigerant will move into the thermostatic expansion valve. High saturated liquid move into thermostatic expansion valve. It is the throttling device which regulates the flow of refrigerant through sensing bulb via capillary tube. It acts like an orifice where sudden pressure drops takes place. Due to this drop in pressure, the temperature also decreases, and due to this temperature and pressure reduction in thermostatic expansion valve, this high pressure saturated liquid converted into the mixture of liquid vapor refrigerant and becomes low pressure, low temperature liquid vapor mixture refrigerant. Okay, liquid is approx 80% and vapor is 20%. Now this low pressure, low temperature mixture refrigerant will goes into the evaporator. Evaporator is another type of heat exchanger where this mixture refrigerant extract heat from the surrounding and changes its phase at constant pressure and becomes at the outlet of evaporator totally vapor refrigerant. Okay, and now we have sensing bulb. Sensing bulb senses that the evaporator, that the refrigerant which came after the evaporator, is it in vapor form or not. If it is in liquid form, it can compress, it can damage the compressor because liquid is incompressible. So sensing bulb got some refrigerant in it and it is connected through the capillary tube through with expansion valve. So in a case of high refrigerant or low refrigerant like a liquid refrigerant, if it is getting after the evaporator, it extract and expand and contract and regulate the flow of refrigerant, and to ensuring that the after evaporator only vapor form of refrigerant comes. Now after evaporator, low pressure, low temperature vapor refrigerant returns again to the compressor and the process continues. Now coming to the temperature at evaporator coil, basically mostly this depends on various factors. The most common thing is that depends on which type of refrigerant we use. Okay, mostly we use tetrafluoroethane, that is R143A. Okay, and for which temperature at evaporator coil for freezer compartment is minus 18 degrees Celsius to minus 20 degrees Celsius, and for vegetable compartment it is 4 degrees Celsius approx. And the condensing pressure at condenser is 10 bar pressure and temperature is 30 bar or 30 degrees Celsius. Thank you.
Okay. So now coming to the ending part of things, give me the laws of thermodynamics.
Laws of, basically there are 3 laws of thermodynamics along with the 4th law, that is the 0th law. I would like to start with the 0th law of thermodynamics, which states that if a body A and body B is in thermal equilibrium and body B and body C is in thermal equilibrium, then the body A and body C will be also in thermal equilibrium. Okay, now coming to the first law. First law is based on the it's the law of conservation of energy, which states that the energy neither be created nor destroyed, and it is given by the formula if heat added to the system is equal to the work done by the system plus increase in the internal energy of the system, Q equal to W plus U, delta U. Now coming to the second law. Second law is known as law of entropy law. and which states that the in an isolated system the entropy will be always increasing, like there will be always increase in entropy given by the formula delta S is greater than 0 and equal that is will be equal to and equal to 0. And now it has got two statement, Clausius statement, Planck statement. Clausius statement said that that it is impossible to transfer the energy from the cold body to the hot body without any external aid. And the Planck statement states that it is impossible to construct a device with only one source without any sink. Okay, there will be the some losses, there will be no such thing that produces 100% efficiency, there will be some heat rejection, that why heat sink is required. The like it is said that there we can't construct a device with a single reservoir. Okay, now coming to the third law. Third law is the law entropy, zero entropy thing. Okay, that the entropy of the substance will tends to zero. The entropy of the pure crystalline substance will be tend to zero if the pressure of the substance will tend to 0 Kelvin degree Celsius, which interprets as that it is impossible to extract all the heat from any substance and make its entropy 0. Okay, entropy is the randomness. So if you extracting the heat, the randomness will be decreasing, but you will never be you will never be able to extract the heat to make the entropy 0. There will be the some randomness in the substance. Thank you.
Okay, so you already mentioned about the boiler safeties and mountings. What about the boiler accessories?
Boiler accessories, we are having that economizer, feed water pump, superheater, air heater.
Okay, tell me about Bernoulli's theorem.
Bernoulli theorem is the theorem based on the law of energy conservation of energy principle. Okay, it states that when an incompressible fluid flow in a streamline, the sum of its kinetic energy, potential energy and pressure energy will be constant throughout the flow, and it has some assumption, that is the fluid should be non viscous, flow should be steady and laminar. These are the coming to the and also it has one extra statement that moving air with high velocity creates a low pressure. Okay, and the fluid moving with high velocity will follow Bernoulli principle. Dynamic fluid will
Okay,
follow Bernoulli principle.
okay. So what is NDT, and explain some different types?
Okay, so NDT is non-destructive type of test that is used to inspect the strength of the material and also if any crack or defects in that without distracting it. There are various type of NDT method, starting with the first one is visual inspection, the second is red dye penetration test, the third is magnetic particle test, fourth is ultrasonic testing, fifth is radiography testing. Now I would like to explain further everything. In visual inspection, we use magnifying glass microscope to check if there is any surface defects or surface holes or anything. In red dye penetration test, there is a dye which is red in color and which we put on the surface, which is type liquid type, which we put on the surface of the specimen, the material which are going to check, and leave it for the some certain period of time. That time is known as dwell time. After that, we use a wide first we separate the excess fluid, and what it does now, that red dye goes into the penetration thing, like if there is some defect it will penetrate it, hence it is named as the red dye penetrant. So after dwell time we remove the excess dye and we put one powder known as white powder, that is called developer. After putting developer, it is more visible, the defects will be more visible under proper lightning condition. Now coming to the magnetic particle inspection, or it is also called electromagnetic test, okay, or electromagnetic crack detector, okay. It uses the application of magnetic field. It is for ferromagnetic material. It uses the application of magnetic field to find the defects on the surface or subsurface. In this, we put metallic particle on the surface of a specimen. We put metallic particle and we apply magnetic field. So what happens, the the flux leakage occurs where whenever there is discontinuity or defect is there, and that flux leakage can be seen by under proper lightning condition. Now coming to the ultrasonic testing. In ultrasonic testing, it can test variety of range of materials. In ultrasonic testing, we use high frequency sound wave, and the application is like we use the reflection property of sound waves and the echo property of sound waves. In this, we have a material and we pass the sound waves, if and we measure, we have a digital screen. If something is reflected from there, it will show some sign of indication that it has some defects, okay. And that is checked by, and the device is called ultrasonic transducer, okay. Now coming to the radiographic testing. In radiographic testing, we use X-rays, gamma rays. We have a material like this here, and X-rays and gamma rays pass through this material. Whenever there is a defect or discontinuity in the material, we have film, and that shows on the film under proper lightning condition. Thank you.
Okay. So final thing, this will be a very subjective thing, which is finally your project
Okay.
explanation. So maybe you can just give some tips on what
Yeah.
should be mentioned,
Yeah.
things like that.
Yeah, see, final year project thing is like you are to know every detail of these things. So, but at my time, I didn't knew about that. Because of Anglo preparation, I just bought my final year project and submitted it. But I had idea if it is can ask. So AVITO brother, thank you for that. He had given me the idea that start with the objective, that why you made it, why it is very important and all the things, then go with the technical. So I started with the objective thing, and I took some of the time. Like my final year project was based on was automatic motorbike stand. So I tell to him that, sir, my final year project is automatic motorbike stand. We are making this because it has not been industrialized yet. And sir, reason is that why we are making this, because most of the accidents are happening because people forgetting to slide the bike stand, okay. So for that reason we are making it automatic, and whenever the switch or self where key switch or self is started by the driver, it get automatically up and down, up and down. We are using DC motor and with sensor. DC motor with gear, we are slowing the speed of DC motor by gear, and we are using the relay switch as a sensor and some of the other thing, push battery and all. And in relay switch is a kind of electronic switch that control the direction of moving up and down and all the thing. I just dragged so much time that he didn't ask me any cross question. Thank you.
Okay, great. So that was the end of this 30 questions. Maybe you can just give some concluding words.
I would like to ask listen your feedback also, but before that I would like to conclude that, see, this is not a very rocket science what I have explained and all the things. It is not a very rocket science thing, very simple. If I make remember the class 4 people, class 4 class student, he will also remember. But behind this simple language, behind this simple answer, everything from the last how many years I am preparing, I had the idea of this how discharge pressure is created, how we shut the discharge valve during starting up pump in my second year, from the second year. But at that time I was not prepared for the interview, how to say the things in a very simple language, not a bookish language. To make it a simple language, it is not just like that I got answer from somewhere and I just mug up and no. From the lots of discussion, from the understanding, from techniques we understand, we discussed and all the techniques, then after I was able to make this short term explanation, like short explanation and in easy language explanation. And now I have got selected. Now it's my responsibility to get uplift my brothers who is in my community, who is there. So for you I am sharing my experience, so further you can get help, because I have gotten help. The AVITO is sitting here. AVITO had helped me from my in very tiny thing. He had inspected or tiny details of mine which can be improved, and it is not easy to get selected by Braganja sir. It was a although a very tough task, but I didn't left any stone unturned. That means मैंने कोई कसर नहीं छोड़ा था. मुझे करना है तो करना है, क्योंकि मुझे पता था ये रॉकेट साइंस नहीं है. इट्स नॉट रॉकेट साइंस. हम एक बार करते हैं. मैं गलती क्या करता था कि पढ़ता था, नोट्स नहीं बनाता था, प्रॉपर आंसर नहीं बनाता था. लॉजिक मुझे पता था, बट इट इज नॉट लाइक दैट यू विल ऑलवेज रिमेंबर द लॉजिक एंड द सीक्वेंस हाउ यू आर टेलिंग इट. यू कैन मेस अप द थिंग्स. So that's why all the things is important, making and when you will be prepare answer by yourself, when you will be revising the things, you will get the you will introspection, you will be introspecting that it can be make better, it can be made better. By improvising it you can make it better. So I did this, and interviewer got very much satisfied with my first two questions in starting, and that he was like, have your relative in engineering, like any sailors? Like he was that much impressed that he was asking from where you are so much cleared. I said no sir, I will be the first generation of my family. So this is the thing. I will say that confidence is the key, and confidence comes from the hard work, from the knowledge you gain. Thank you so much, Avito, for having your time and giving me the opportunity to speak up all the answers.
Yeah, no issues. Thank you. So I think we can call it a day on this, and then if they have questions, they can put it in the comments, right? Or in WhatsApp.
Yeah, in the comments they can put. If anything they like, they can also put in the comment, and if anything they find a doubt in that, they can also put in comment. Okay, we will further discuss all about that. Thank you so much.
Okay, I think we can wind up there.
Okay.